Okay, so we're going to take a look at a couple more examples where we are calculating um, both the infusion time and then also the total volume of the bag. So we're going to kind of combine some of these concepts that we've been talking about here. Now, in this chapter, you do have a lot of word problems where you're going to be given a lot of information. So once again, really read through the problem a few times to make sure that you understand what the question is asking and that you also don't use any information that is not relevant to what you're trying to solve for. So let's take a look at number 10. A physician is ordering amphotericin B 20 milligrams of an IV piggyback in 150 mils of dextrose 20% in water. That is to be infused at 20 drops per minute with a drop factor of 15 drops per mil. First question, how many mils of stock solution should be added to the bag if the stock available is 50 milligrams per 20 mils? Okay, so a lot of information here. We're looking for mils of stock solution. So let's keep that in mind. We want to find milliliters of stock. And they just told us that our stock available is 50 milligrams per 20 milliliters. So let's read through this again. We have a strength 50 milligrams per 20 mils. We're looking for how many mils of stock should be added to the bag. So let's read this one more time. They're ordering amphotericin B 20 milligrams in 150 mils of D20W. So this is just our IV bag, right? This is our IV bag. We want to put 20 milligrams of amphotericin B into that bag. And then they give us the drip rate and the drop factor. So what's really important here is this order. They're ordering 20 milligrams to be put into the bag. The question says, how many mils of stock, excuse me, should be put into the bag? Well, we know our stock, there's 50 milligrams of our drug in every 20 mils of that solution. And it's saying how many mils of this solution do we need to get our order of 20 milligrams. So mils of stock, that's what I'm looking for. They're asking for how many mils will give us my order of 20 milligrams. So here, they're just asking us to solve for the dose volume. So what can we pull out of this vial to give us our 20 milligrams that we need to then add to this bag? So when we solve for X here, 20 times 20 gives us 400. So 400 equals 50X. We're going to divide by 50 here, divide by 50 here. So 400 divided by 50, X equals 8 milliliters. So we're going to need 8 milliliters of our stock solution to add to our bag, okay? So I want you to picture this, okay? We have a vial that is 50 milligrams per 20 mils. And we also have a piggyback bag that is 150 mils of D20W. That's not important, that's just our bag, right? So in our vial, we just said that we need to draw out 8 mils from this vial because that will give us the 20 milligrams. And then we're going to add that to our bag here. So we're taking 8 mils out of here, adding that to our bag. So the second question says, what is the total volume to be infused? Well, if there was already 150 mils in the bag, 150 mils plus the 8 mils that we just added would be a total of 158 milliliters in the bag. Now this next question says, how long will the infusion last? How long? They're asking for time. Okay, so we know that we need to look for something relative to time. If we read through here, the only thing that we know about time is 20 drops per minute. So when we're looking for time here, let's start with minutes. And then if we need to, we can go back and convert that into hours and minutes. I'll just get rid of this so it's not in our way. So dimensional analysis, we're starting with minutes. We always want to have minutes on top. We know that in 1 minute, 20 drops are running. So we have 1 minute and 20 drops are running in every minute. Next step, start with a fraction that has this denominator in the numerator of the second fraction. So we've already used drops per minute. The only thing we know about drops other than that is we have a drop factor of 15 drops per mil. So I know that there's 15 drops in every 1 milliliter. So now we can get rid of that. My drops are going to cancel out. Right now I'm left with minutes per mil. Well, I only want to be left with minutes. So I need to get rid of this milliliter. So I can multiply by a fraction that has milliliters in top. Now, it's saying how long will the infusion last? So we need to figure out how many mils is in the bag. Well, we just said that we have to add 8 mils to that bag. So it's a total of 158 mils in the bag. So if the bag is 158 milliliters, once again, this is by itself. There's nothing attached to that. So we can just put that over 1 to make sure it stays in the numerator here. Now my mils will cancel out. I'm only left with minutes here, which is what I want. So now I can solve. Once again, it's kind of running together, so I'll block that off there. So when we are solving, once again, multiply straight across. So 15 times 158 gives me 2,370. And then 20 times 1 is just 20. So I'm going to take that number here divided by 20, and that leaves me with 118.5 minutes. Now, if I want to go back and convert this into hours and minutes, let's just round this. We'll say 119 minutes to make it even there. We don't want to get into seconds here. So if I want to convert this into hours and minutes, remember I can just take this divided by 60. So 119 minutes divided by 60 minutes per hour. 119 divided by 60, that gives me 1.98 hours. And then if I want to go back into hours and minutes, I can take this 0.98 times 60. That leaves me with roughly 59 minutes. So 1 hour and 59 minutes. Now we can see that that makes sense because we know that 1 hour is 60 minutes. So 60 minutes plus 59 gives us 119 minutes, okay? So final time there, 1 hour and 59 minutes. Now I know that that was a lot going on here, So what I would suggest you do is pause the video, go back to the beginning of this question and re-watch what exactly we did here to make sure that you understand where this information is coming from, okay? And if you're still struggling with this, please let me know. Send me an email, shoot me a text, and we can go over this together. And then using this example on number 10, I want you to solve number 11. It is very similar to number 10. The only difference here is that you're going to have to find the drip rate at the end, or the drop rate. Remember, drop rate is always drops per minute. So go ahead, rewatch number 10, what we just did, and then do number 11 on your own. Once you complete number 11, both 10 and 11 and number 9 that we went through earlier should help you with practice problems D. So after you get to that point, go ahead and work on practice problems D out of the book.